This question is to find estimator for the parameter of a given probability distribution. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Thank you so much. A population has the following probability distribution. The probability that x equals -1 is 2 times theta. The probability that x equals 0 is theta. The probability that x equals 1 is 1 minus 3 times theta. Theta is between 0 and 1/3. A sample is observed. 1, 0, -1, 1, 1, -1. Which option correctly gives the method of moments estimator of theta and the maximum likelihood estimator of theta? There are 4 options. First step, method of moments. The theoretical mean of x is computed as follows. Multiply -1 by 2 times theta, then add 0 times theta, then add 1 times the quantity 1 minus 3 times theta. After simplifying, the theoretical mean becomes the number 1 minus 5 times theta. Next, compute the sample mean. Add the 6 observations, which gives 1 plus 0 minus 1 plus 1 plus 1 minus 1, resulting in 1. Divide this total by 6 to obtain the sample mean, which equals 1/6. Set the theoretical mean equal to the sample mean. This gives the equation 1 minus 5 times theta equals 1/6. Solving this equation yields theta equal to 1/6, which is the method of moments estimator. Common mistake. Students often forget that the probability attached to -1 is 2 times theta, not theta. Then, next step, maximum likelihood estimator. Count the sample values. -1 occurs twice, and each such value contributes a probability of 2 times theta. 0 occurs once with probability theta. 1 occurs 3 times with probability 1 minus 3 times theta. Therefore, the likelihood is the product of the following 3 parts. The term 2 times theta appears twice. The term theta appears once. The term 1 minus 3 times theta appears 3 times. Multiplying these give a likelihood proportional to 4 times theta cubed times the quantity 1 minus 3 times theta raised to the 3rd power. Take the natural logarithm of the likelihood. This gives a constant term, plus 3 times the natural logarithm of theta, plus 3 times the natural logarithm of the quantity 1 minus 3 times theta. Differentiate this log likelihood with respect to theta. The derivative becomes 3 divided by theta minus 9 divided by the quantity 1 minus 3 times theta. Combine these terms into a single expression. The numerator is 3 minus 18 times theta, and the denominator is theta times the quantity 1 minus 3 times theta. Set the derivative equal to 0. This gives the simple equation 3 minus 18 times theta equals 0. Solving gives theta equal to 1/6. This value lies inside the allowable interval from 0 to 1/3, so it is the valid maximum likelihood estimator. Common mistake, forgetting to check that the critical point lies inside the allowed range of theta. Final answer. The correct choice is option C. Both the method of moments estimator and the maximum likelihood estimator of theta are equal to 1/6. Always match each sample frequency with its corresponding probability before forming either a moments equation or a likelihood function. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.